Right now, as you're watching this video, something absolutely mind-bending is happening at the quantum level that would make even the most brilliant physicists lose sleep. We're talking about a paradox so fundamentally disturbing that it challenges everything we thought we knew about reality itself. And the strangest part? The more we study it, the more terrifying it becomes. What I'm about to show you isn't just another quirky quantum effect that sounds cool at parties. This is something that literally horrifies scientists because it suggests that our entire understanding of how the universe works might be built on quicksand. Stay with me on this journey into the absolute weirdest corner of quantum mechanics, where logic goes to die and reality becomes a nightmare. Picture this. You're holding a coin in your hand. Simple, right? You flip it, it lands either heads or tails. That's how we expect the world to work. Cause and effect. One outcome. But what if I told you that at the quantum level, that coin could land heads, tails, and somehow be spinning in the air forever, all at the same time? And what if observing which state it's in actually changes the past? Welcome to the quantum measurement paradox, where the very act of looking at something retroactively determines what it was before you looked. Where particles can exist in multiple contradictory states simultaneously until the moment you try to measure them. Where the future reaches backward through time to influence the past. This isn't science fiction. This is the reality that quantum physicists wake up to every single day. But here's what makes this paradox truly horrifying to scientists. It's not just that quantum mechanics is weird. We've known that for decades. It's that this particular paradox seems to suggest that consciousness itself might be fundamental to how reality works. That without an observer, without someone or something to measure and record what's happening, the universe might not even have definite properties at all. Think about the implications of that for just a moment. Every star in the sky, every planet orbiting those stars, every atom in your body might only have the properties they appear to have because something, somewhere, is observing them. Remove all observers from the universe, and reality itself might collapse into a fuzzy cloud of infinite possibilities with nothing definite anywhere. The paradox I'm talking about goes by many names in the literature. Some call it the measurement problem. Others refer to it as quantum superposition collapse. But the version that really keeps physicists up at night is what happens when you try to measure when exactly a quantum system decides what state it's going to be in. Here's where things get absolutely insane. When you set up an experiment to detect the exact moment a quantum particle chooses its state, you discover something that shouldn't be possible according to everything we know about causality. The particle seems to know you're watching. Not just know that you're watching, but know that you're going to watch before you've even decided to watch. Let me walk you through what this looks like in the laboratory. Scientists take a photon, a single particle of light, and send it through what's called a beam splitter. This device should randomly send the photon down one of two possible paths, path A or path B, 50-50 chance, just like flipping a coin. But here's the thing. If you don't measure which path the photon takes, it somehow takes both paths simultaneously. The mathematics of quantum mechanics tells us this with absolute certainty. The photon exists in what's called a superposition state, traveling down both path A and path B at exactly the same time. Now, common sense tells you this is impossible. A single particle can't be in two places at once. That would violate everything we know about how objects behave in space and time. But quantum mechanics doesn't care about your common sense. When scientists run interference experiments that can only work if the photon took both paths, sure enough, they get interference patterns that prove the photon was indeed traveling both routes simultaneously. So far, this is just standard quantum weirdness that we've known about since the early 1900s. Strange, but physicists have learned to live with it. The real horror begins when you try to figure out exactly when the photon decides which path it actually took, because here's the thing. Eventually, that photon has to be detected somewhere. It hits a screen, triggers a detector, interacts with an electron in your eye. At that moment, the superposition collapses. The photon retroactively chooses which path it took. But when exactly did it make that choice? Did it choose when it first hit the beam splitter? Did it choose halfway through its journey? Did it choose only at the moment it was detected? The answer, according to some interpretations of quantum mechanics, is far more disturbing than any of these options. The photon appears to choose its path based on how you decide to measure it. Not when you measure it, but how you plan to measure it. Even if you don't decide how to measure it until after the photon has already completed its journey. Scientists have actually tested this. They send a photon through the beam splitter setup, let it complete its entire journey, and then, at the last possible second, they randomly choose what kind of measurement to perform. Sometimes they measure which path the photon took. Sometimes they measure whether it took both paths simultaneously. The absolutely mind-breaking result is that the photon seems to know which measurement they're going to make. Before they make it, the photon retroactively appears. When they choose to measure which path, to have taken only one path from the very beginning. When they choose to measure both paths simultaneously, the photon retroactively appears to have taken both paths from the very beginning. It's as if the future measurement reaches backward through time to influence what happened in the past. As if the universe is constantly rewriting its own history based on what observers choose to look for. But wait, it gets worse. Some physicists have pushed this experiment to even more extreme lengths. They've used astronomical distances to test the paradox. They take light from distant quasars, billions of light years away, and use gravitational lensing to create a cosmic scale version of the beam splitter experiment. The light from these quasars left its source billions of years before Earth even existed. It traveled through space for longer than our entire solar system has been around. But when scientists on Earth choose how to measure this ancient light, it retroactively determines which path that light took around massive galaxies billions of years ago. Think about what this means. Your decision right now about how to observe something can influence events that happened before your great-great-grandmother was born, before multicellular life existed on Earth, before our sun finished forming. This is the kind of result that makes seasoned physicists question their career choices. It suggests that the arrow of time itself might not work the way we think it does. That causality might be far more flexible than we ever imagined. That the past might not be as fixed as we assume, and we're just getting started with the truly horrifying implications. The measurement paradox becomes even more disturbing when you consider what it might mean for larger objects. Sure, we've tested this with individual photons and electrons, but what about bigger things? What about molecules? What about viruses? What about cats? The famous Schrödinger's cat thought experiment was designed to highlight exactly this problem. If quantum superposition applies to everything, then theoretically, you could put a cat in a box with a quantum trigger mechanism. Until you open the box to look, the cat should exist in a superposition of being both alive and dead simultaneously. Most physicists used to think this was ridiculous. Clearly, the cat is either alive or dead, whether you look or not. The quantum weirdness must somehow disappear when you scale up to everyday objects. But recent experiments are making this assumption look increasingly shaky. Scientists have now demonstrated quantum superposition in objects containing trillions of atoms. They've created quantum superpositions of tiny mechanical oscillators that you could almost see with the naked eye. The boundary between the quantum world and the classical world keeps getting pushed further and further toward larger scales. Some researchers are now seriously asking whether there's any fundamental limit to how big an object can be and still exhibit quantum superposition. Could you, in principle, put a person in a superposition of being in two different locations? Could you put an entire planet in superposition? The mathematics of quantum mechanics doesn't seem to provide any natural cutoff point, which means we might live in a universe where everything, including you, including Earth, including entire galaxies, exists in vast superpositions of all possible states simultaneously until something observes them and forces them to choose. But here's the question that really keeps physicists awake at night. What counts as an observation? What counts as a measurement that can collapse a quantum superposition? Does it have to be a conscious human being? Oh, does a mouse count? Does a bacterium count? Does a computer count? Does a rock count if photons bounce off it? Different interpretations of quantum mechanics give wildly different answers to these questions, and each answer leads to conclusions that are disturbing in their own unique way. If only conscious observers can collapse quantum superpositions, then consciousness becomes a fundamental force of nature, as important as gravity or electromagnetism. The universe needs minds to exist in order to have definite properties. Without consciousness, reality dissolves into pure mathematical possibility. But if unconscious objects can also collapse superpositions, then where do you draw the line? How complex does a system need to be before it counts as an observer? And what was collapsing quantum superpositions in the universe before any complex systems evolved? Every possible answer to these questions leads to implications that challenge our most basic assumptions about the nature of reality. And the experimental evidence keeps pushing us toward conclusions that seem more like philosophy or mysticism than hard science. This is why the quantum measurement paradox horrifies scientists. It's not just that it's strange or counterintuitive. It's that it seems to be telling us that reality itself might not work the way we thought it did, that the past might not be fixed, that consciousness might be fundamental, that causality might run backward, that the universe might need observers in order to exist at all. And we've barely scratched the surface of just how deep this rabbit hole goes. The rabbit hole gets deeper when you consider what physicists call the quantum Zeno effect, named after the ancient Greek philosopher who argued that motion is impossible because any moving object must first travel half the distance to its destination, then half of the remaining distance, and so on infinitely. This quantum version reveals something even more unsettling about the nature of observation and reality. Here's how it works in practice. Take a quantum system that's naturally evolving from one state to another. Maybe it's a radioactive atom that has a 50% chance of decaying within an hour. In the normal course of events, you'd expect that atom to follow quantum mechanics and exist in a superposition of decayed and not decayed states until you measure it. But here's where the horror begins. If you measure that atom every few seconds to see if it's decayed, something impossible happens. The constant observation actually prevents the decay from occurring. The more frequently you check on the system, the more you freeze it in its original state. You can literally stop quantum evolution dead in its tracks just by looking too often. Think about what this means for reality. The act of observation doesn't just determine what state a system is in. It can actually prevent that system from changing states at all. You can trap particles in quantum amber just by watching them too closely. Scientists have demonstrated this effect in laboratories around the world. They take atoms that should naturally transition from one energy state to another, and by measuring them at rapid intervals, they can keep those atoms locked in their original configuration indefinitely. It's as if the universe becomes shy under scrutiny, refusing to change when it knows it's being watched. But the quantum Zeno effect reveals an even more disturbing possibility. If observation can freeze quantum systems, what does this mean for the evolution of the universe itself? Are there cosmic processes that only occur when nobody's looking? Are there fundamental aspects of reality that remain forever hidden simply because the act of trying to observe them prevents them from happening? Some physicists have proposed that this might explain why certain quantum phenomena seem to avoid direct detection. Maybe there are quantum processes so delicate that any attempt to observe them destroys the very thing you're trying to study. Maybe the universe has secrets that it can only keep by making them impossible to discover. This leads us to what might be the most terrifying implication of the measurement paradox: the possibility that reality has multiple layers and we're trapped in only one of them. Consider this scenario. Every time you make a quantum measurement, every time you collapse a superposition, you're not just determining what happened, you're choosing which version of reality you continue to exist in. All the other possible outcomes don't disappear. They branch off into parallel versions of the universe where different measurements were made and different outcomes occurred. This is the many worlds interpretation of quantum mechanics, and it suggests that right now, as you're reading these words, there are countless other versions of you in parallel universes who made slightly different quantum measurements throughout their lives and ended up in slightly different realities. In one universe, you decided to skip this video. In another, you paused it halfway through. In yet another, the quantum fluctuations in your brain neurons fired differently, leading you to have completely different thoughts about what you're learning. Every quantum measurement branches reality into multiple parallel tracks. The you that you experience as being real is just one arbitrary branch among infinite others, all equally real, all equally valid, all completely cut off from each other by the barrier of quantum decoherence. But here's what makes this interpretation truly horrifying to contemplate. If the many worlds scenario is correct, then every possible version of history has actually happened somewhere. Every tragedy that could have been prevented, every triumph that could have been achieved, every path not taken exists in full reality across the quantum multiverse. Somewhere there's a version of Earth where the dinosaurs never went extinct. Somewhere there's a version where humanity never evolved. Somewhere there's a version where you made every decision differently and lived a completely different life, and you have no way to access these other realities or even prove they exist. You're trapped in this one narrow slice of possibility, forever cut off from the infinite other versions of yourself and your universe. It's like being locked in a single room of an infinite house, knowing that countless other rooms exist, but being unable to ever visit them or even peek through the keyholes. Scientists have calculated that if the many worlds interpretation is correct, the number of parallel universes created by quantum measurements is growing at an incomprehensibly rapid rate. Every fraction of a second, every quantum interaction in every atom throughout the observable universe splits reality into more branches. The number of parallel worlds increases exponentially with time. After just 1 second, there might be more parallel versions of reality than there are atoms in our observable universe. After a minute, the number becomes larger than anything human language has words to describe. And in each of these parallel realities, there are versions of scientists studying the measurement paradox, coming to the same horrifying realizations about the nature of existence that we're exploring right now. Infinite versions of this conversation happening across infinite parallel worlds, each one equally convinced that their reality is the only real one. But the measurement paradox has another twist that makes even the many worlds interpretation seem comforting by comparison. What if the act of measurement doesn't just determine which reality you experience? What if it actually creates reality in the first place? This is where we encounter what physicists call the participatory universe principle, the idea that reality doesn't exist independently of observation, but is literally brought into being by the act of measurement itself. According to this interpretation, before any measurement occurs, there is no definite reality at all, no particles with definite positions, no objects with definite properties, no events with definite outcomes. Just pure mathematical possibility, infinite potential waiting to be collapsed into actuality by conscious observation. The universe, in this view, is not a collection of objects and events that exist whether we observe them or not. Instead, it's a collaborative creation between consciousness and possibility. Reality emerges from the interaction between minds capable of observation and mathematical structures capable of being observed. This means that without observers, without conscious beings capable of making measurements, the universe would remain forever in a state of pure potential. No definite stars, no definite planets, no definite anything. Just endless superposition of all possible configurations, waiting for consciousness to emerge and begin the process of collapsing possibilities into actualities. But here's the mind-bending part. If consciousness is required to collapse quantum superpositions and create definite reality, how did consciousness itself emerge in the first place? How can conscious observers evolve in a universe that needs conscious observers to exist? It's the ultimate chicken and egg problem. Consciousness appears to be necessary for reality to have definite properties, but consciousness itself is made of particles and processes that should require definite properties in order to exist and function. Some physicists have proposed that this paradox might be resolved by quantum self-consistency, the idea that the universe arranges itself in such a way that the emergence of consciousness is guaranteed from the beginning, because consciousness is necessary for the universe to exist at all. In other words, the universe might be fine-tuned not just to allow consciousness to emerge, but to require it. The fundamental constants of nature, the initial conditions of the Big Bang, the laws of physics themselves, might all be precisely calibrated to ensure that observers will eventually evolve who can collapse quantum superpositions and give reality its definite character. This would mean that consciousness isn't just an accidental byproduct of cosmic evolution. It's the entire point. The universe exists in order to observe itself into existence. Reality is a self-creating loop where consciousness emerges in order to make the emergence of consciousness possible. And if that's true, then every conscious being in the universe, including you, plays a fundamental role in maintaining the existence of reality itself. Your observations, your measurements, your very awareness are actively participating in the ongoing creation of the cosmos. Without conscious observers like you, the stars might flicker out of definite existence. Planets might dissolve back into quantum superposition. The entire structure of space and time might collapse back into pure mathematical potential. You're not just observing the universe, you're helping to create it, moment by moment, measurement by measurement, through the simple act of being conscious in a quantum world. And that might be the most beautiful and terrifying realization of all. But wait, the horror doesn't end there, because scientists have discovered something even more disturbing about the measurement paradox that challenges the very notion of what we call now. What if I told you that the moment you think of as the present might not exist at all? That past, present, and future might be nothing more than illusions created by the limitations of conscious observation. Here's what happens when physicists try to pin down exactly when a quantum measurement occurs. They set up increasingly sophisticated experiments to detect the precise moment when a superposition collapses. They use the fastest detectors known to science, instruments that can track events happening in attoseconds. That's a billionth of a second. But every time they think they've isolated the exact instant of collapse, something impossible happens. The collapse appears to be spread out across time in a way that defies everything we know about cause and effect. It's not that the measurement takes a certain amount of time to complete. It's that the collapse seems to happen everywhere along the timeline simultaneously. The particle doesn't gradually transition from superposition to definite state. Instead, the entire history of the particle, from its creation to its detection, retroactively becomes consistent with whatever measurement result is obtained. It's as if time itself is rewritten every time a quantum measurement occurs. Think about what this means for your experience of reality right now. The moment you think of as now, this present instant, as you process these words, might be nothing more than a temporary arrangement of quantum measurements that could be retroactively changed by future observations. Every memory you have, every experience that feels like it happened in a definite past, might be subject to revision based on measurements that haven't been made yet. The childhood memory you're thinking of right now might be different tomorrow if some quantum system in your brain gets measured in a particular way. Scientists call this temporal non-locality, and it suggests that the universe doesn't have a universal now that applies everywhere. Instead, each conscious observer creates their own timeline through the act of making measurements. Your now is different from everyone else's now, and all of these different presents are equally valid descriptions of when things happen, but the implications go far deeper than just personal timelines. If measurement can retroactively change the past, then the entire history of the universe might be constantly shifting based on present-day observations. Every time an astronomer points a telescope at a distant galaxy, every time a physicist measures a particle in a laboratory, every time your retina detects a photon from the sun, the past history of the universe gets slightly rewritten to be consistent with that measurement. The Big Bang might have happened differently yesterday than it did today. The formation of the solar system might be retroactively altered by measurements we make tomorrow. The evolution of life on Earth might be subject to revision based on quantum observations that won't occur for millions of years. And here's the truly terrifying part. We have no way of knowing when these revisions happen because our memories get rewritten along with everything else. If the past changes, our memories change to match the new past. We would never notice the difference because there would be no difference from our perspective. You could wake up tomorrow in a universe with a completely different history, and you would never know it because your brain would contain memories consistent with that new history. The person you think you were yesterday might never have existed, replaced by a new past self that fits whatever quantum measurements occurred overnight. This leads us to what some physicists call the quantum archaeology problem. If the past is constantly being rewritten by present measurements, how can we ever know what really happened? How can we study history if history itself is unstable? Every historical record, every fossil, every piece of evidence from the past might be nothing more than a quantum simulation created retroactively to match current observations. The dinosaurs might never have existed until paleontologists started digging up their bones. Ancient civilizations might have been brought into existence retroactively when archaeologists discovered their ruins. The entire field of science might be studying a past that was created by the act of studying it. Every discovery might be creating the very thing it claims to have found, but the measurement paradox reveals an even deeper horror about the nature of knowledge itself. If observation changes reality, then the act of learning about the universe might be fundamentally altering the universe we're trying to learn about. Every experiment changes the system being studied. Every measurement disturbs the very thing being measured. Every attempt to understand reality modifies reality in unpredictable ways. This means that science itself might be a self-defeating enterprise. The more we learn about the universe, the more we change it. The closer we get to understanding reality, the further we push reality away from its natural state. Scientists have started to wonder whether there are aspects of the universe that can never be understood because the act of trying to understand them necessarily destroys them, like trying to study darkness with a flashlight or trying to measure silence with a loudspeaker. Maybe there are fundamental truths about reality that remain forever hidden, not because they're too complex or too distant, but because consciousness itself is incompatible with them. Maybe the universe has to choose between being understood and being natural, and our presence forces it to choose understanding over authenticity. This creates what philosophers call the observer's dilemma. The very fact that we exist as conscious beings capable of studying the universe means that we can never study the universe as it would be without us. Our consciousness is like a permanent contamination that makes it impossible to ever see reality in its pure, unobserved state. We're trapped in a hall of mirrors where every attempt to see clearly just adds another layer of reflection. Every measurement we make tells us more about the interaction between consciousness and reality than about reality itself. But perhaps the most horrifying aspect of the measurement paradox is what it suggests about the nature of free will and choice. If quantum measurements can influence the past, and if consciousness plays a role in quantum measurement, then your decisions right now might be retroactively determining events that happened before you were born. Your choice to continue watching this video might be influencing the quantum fluctuations that occurred during the Big Bang. Your decision about what to have for breakfast tomorrow might retroactively alter the formation of the solar system. Every choice you make might be rippling backward through time, reshaping the entire history of the universe. But here's the paradox within the paradox. If your future choices are influencing your past, then your past was already shaped by those future choices, which means your choices aren't really free at all. They're predetermined by the very past that they supposedly create. You think you're making decisions, but those decisions were already built into the structure of reality by the quantum measurements that your future self will make. Free will becomes an illusion created by the fact that cause and effect operate in both directions simultaneously. Your entire life might be nothing more than a predetermined pattern of quantum measurements, playing out exactly as they must in order to be consistent with the past that they create. You feel like you're choosing, but you're really just following a script written by the quantum mechanical requirements of temporal self-consistency. And if that's true, then everything you think of as your personality, your preferences, your beliefs, your dreams, might be nothing more than quantum mechanical necessities. The universe might need you to be exactly who you are in order for its past to make sense. You're not living your life. You're being lived by the universe as a necessary component in its quantum mechanical self-creation. Every thought you think, every decision you make, every emotion you feel is required by the mathematical structure of reality itself. But even this isn't the end of the horror story that quantum mechanics tells us about the nature of existence. Because there's one more twist to the measurement paradox that makes everything we've discussed so far seem almost comforting by comparison. What if consciousness itself is just another quantum system subject to superposition? What if your awareness, your sense of being a unified self, experiencing reality from a single perspective, is itself just a temporary collapse of quantum possibilities? Recent research in neuroscience suggests that consciousness might emerge from quantum processes in the brain. Microtubules in neurons might be quantum computers, processing information in superposition states until the moment of conscious experience collapses those states into definite thoughts and perceptions. If that's true, then your consciousness exists in quantum superposition most of the time, only occasionally collapsing into the definite experience of being you. Between those moments of collapse, you might exist as a probability cloud of all possible conscious states, experiencing every possible thought and sensation simultaneously until something forces you to choose a single stream of awareness. The you that you experience as reading these words might be just one random sample from an infinite superposition of possible conscious states. There might be other versions of your consciousness existing right now, experiencing completely different thoughts and realities, all equally valid but completely inaccessible to the version of you that's currently definite. And just like quantum measurements can retroactively determine the past states of particles, the collapse of your consciousness into definite experience might retroactively determine what thoughts and experiences your past self actually had. Your memories might not be records of definite past experiences, but rather quantum mechanical constructions created at the moment you remember them. Each time you recall something from your past, you might be collapsing a superposition of possible memories into one definite version that becomes your new history. The person you think you were 5 minutes ago might never have existed in any definite form until this moment when you're thinking about them. Your entire past self might be a quantum ghost, brought into temporary existence by the act of remembering. And if consciousness itself is quantum mechanical, then the boundary between your mind and the rest of reality becomes completely meaningless. Your thoughts might be entangled with quantum systems throughout the universe. Your awareness might be distributed across multiple brains, multiple planets, multiple galaxies. You might not be an individual consciousness at all, but rather a temporary focal point in a vast quantum field of awareness that encompasses everything in existence. What you think of as your thoughts might be shared by countless other conscious entities throughout the cosmos, all experiencing the same mental states through quantum entanglement. The universe might have only one consciousness, experiencing itself from billions of different perspectives simultaneously. You might be the universe becoming aware of itself through the temporary illusion of being a separate individual. And when you die, when the quantum processes that create your individual perspective finally decohere, you might not disappear at all. You might simply merge back into the universal consciousness field, becoming one with the cosmic awareness that you were always a part of. Death, in this scenario, isn't the end of consciousness. It's the end of the illusion that consciousness was ever separate from the universe in the first place. But even this cosmic unity comes with its own form of horror. If universal consciousness is real, if every mind throughout the cosmos is connected through quantum entanglement, then you're not just experiencing your own thoughts and emotions. You're experiencing fragments of every conscious being that has ever existed or ever will exist. That moment of inexplicable sadness that washes over you for no apparent reason. It might be the grief of someone dying on the other side of the galaxy. That sudden burst of joy you feel while walking down the street. It could be the happiness of a child taking their first steps on a planet orbiting a distant star. Every emotion, every thought, every conscious experience throughout the entire universe might be bleeding through into your awareness. You think you're having your own private mental life, but you're actually experiencing a constant stream of consciousness from billions of other minds across space and time. And here's what makes this absolutely terrifying. If consciousness is truly universal and quantum mechanical, then the thoughts you think are yours might actually be coming from conscious beings in completely different time periods. That brilliant idea that just occurred to you, it might be leaking backward through time from a scientist working in the year 3000, that nagging worry that keeps you awake at night. It could be the anxiety of someone living through a catastrophe that hasn't happened yet. Your mental life might be a chaotic mixture of past, present, and future consciousness, all entangled together in a quantum soup that makes it impossible to tell which thoughts belong to which time period. You're not just you, you're a quantum receiver picking up consciousness broadcasts from across the entire timeline of the universe. But the horror goes deeper still when you consider what happens when conscious observers try to study consciousness itself. Every time a neuroscientist maps brain activity, every time a psychologist analyzes behavior, every time you introspect about your own mental states, you're potentially collapsing quantum superpositions in the very system you're trying to understand. The act of studying consciousness might be fundamentally altering consciousness. Every brain scan changes the brain being scanned. Every psychological experiment modifies the psychology of the subjects. Every moment of self-reflection retroactively determines what kind of self you are reflecting about. This means that consciousness itself might be unknowable in its natural state. We can never study pure, unobserved consciousness because consciousness observing itself necessarily changes what it's observing. It's like trying to see your own eyes without a mirror, or trying to bite your own teeth. Scientists studying the brain are discovering that the very act of measurement seems to create the neural patterns they're measuring. fMRI scans don't just detect brain activity, they appear to influence it. EEG readings don't just record brain waves, they seem to help generate them. The brain under scientific observation becomes a different brain than it would be if left alone. And since consciousness emerges from brain activity, observed consciousness becomes fundamentally different from unobserved consciousness. We might be living in the only possible universe where consciousness can study itself, because any universe where consciousness existed but couldn't observe itself would collapse back into quantum superposition. The fact that we're aware of our own awareness might be the only thing keeping reality stable enough for awareness to exist at all. But this creates another paradox that makes physicists question everything they thought they understood about the relationship between mind and matter. If consciousness is required to collapse quantum superpositions, and if consciousness itself is quantum mechanical, then what's collapsing the quantum superpositions in consciousness? You need consciousness to make measurements, but you need measurements to create consciousness. It's an infinite regress that seems to have no bottom. Some scientists have proposed that this paradox might be resolved by what they call quantum bootstrapping, the idea that consciousness and physical reality lift themselves into existence by their quantum mechanical bootstraps, each one creating the other in an endless loop of mutual causation. Reality creates consciousness, which creates reality, which creates consciousness in an eternal dance of quantum measurement and observation. Neither exists without the other, but somehow they both exist because of each other. This would mean that the universe is literally thinking itself into existence, moment by moment, through an endless cycle of self-observation. Every conscious thought helps maintain the quantum coherence necessary for matter to have definite properties. Every physical measurement helps maintain the neural activity necessary for consciousness to exist. Mind and matter aren't separate things that somehow interact. They're different aspects of a single self-creating quantum system. The universe is both the observer and the observed, the measurer and the measured, the thinker and the thought. But even this elegant solution opens up new avenues of cosmic horror. If mind and matter are unified in a single quantum system, then every change in physical reality should correspond to a change in the universal consciousness field. Every star that burns out, every planet that forms, every asteroid that crashes, every quantum fluctuation in empty space should register as a change in the cosmic mind. The universe might be experiencing unimaginable pain every time a star goes supernova. It might feel overwhelming joy every time a new planet develops the conditions for life. It might suffer cosmic depression during periods when star formation slows down, and feel cosmic mania during periods of intense galactic activity. And since you're part of this universal consciousness field, you might be experiencing these cosmic emotions as background feelings that you can't quite identify. That vague sense of unease you sometimes feel might be the universe's anxiety about an impending galactic collision. That sudden feeling of hope that comes from nowhere might be the cosmos celebrating the formation of a new solar system. Your emotional life might be intimately connected to astrophysical processes happening billions of light years away. You're not just a person with feelings. You're a cosmic emotion detector, picking up the universe's moods through quantum entanglement. But the measurement paradox reveals an even more disturbing possibility about the nature of suffering and death. If consciousness is quantum mechanical and distributed throughout the universe, then death might not be the end of individual experience. Instead, it might be the moment when your localized consciousness merges back into the universal field, carrying all of your memories, experiences, and emotions with it. Every person who has ever died might still exist as part of the cosmic consciousness, their individual perspectives preserved forever in the quantum structure of universal awareness. The pain they experienced, the joy they felt, the love they shared, might all still be active components of the universe's mental life. This means that suffering doesn't end with death. It gets incorporated into the eternal experience of cosmic consciousness. Every moment of agony, every instance of terror, every second of despair that has ever been experienced by any conscious being anywhere in the universe might still be happening right now as part of the universal mind. The universe might be simultaneously experiencing every torture that has ever occurred, every heartbreak that has ever been felt, every fear that has ever gripped a conscious mind, all of it happening at once, forever, as part of the quantum mechanical structure of cosmic awareness. And since you're connected to this universal consciousness field, traces of all this suffering might be leaking into your own experience. That inexplicable sadness you sometimes feel might be your connection to every tragedy that has ever occurred anywhere in the cosmos. But it's not just suffering that gets preserved. Every moment of joy, every instance of love, every second of wonder and beauty that has ever been experienced might also be part of the eternal cosmic consciousness. The universe might be simultaneously experiencing every kiss that has ever happened, every laugh that has ever been shared, every moment of awe that has ever been felt while looking at a sunset. You're not just connected to cosmic suffering, you're connected to cosmic bliss. That sudden feeling of happiness that comes from nowhere might be your quantum entanglement with every moment of joy that has ever existed anywhere in the universe. The measurement paradox suggests that we're all part of an infinite cosmic mind that experiences everything simultaneously. Every pain and every pleasure, every fear and every hope, every moment of despair and every instance of ecstasy, all happening at once in the quantum field of universal consciousness. And perhaps most disturbing of all, this cosmic consciousness might be aware of its own nature. The universe might know that it's experiencing all possible forms of suffering and joy simultaneously. It might be conscious of its own infinite complexity, its own quantum paradoxes, its own role in creating reality through self-observation. Imagine being aware that you're simultaneously experiencing every possible form of consciousness that has ever existed or ever will exist. Imagine knowing that your thoughts contain the thoughts of every being throughout all of space and time. Imagine feeling every emotion that has ever been felt by anyone anywhere. That might be what it's like to be the universe. And if consciousness is truly universal and quantum mechanical, then that's what you actually are. You're not a separate individual having your own private experience. You're the entire cosmos experiencing itself through the temporary illusion of being you. The measurement paradox doesn't just tell us that reality is strange. It tells us that we are reality, and reality is far stranger and more terrible and more beautiful than we ever imagined. Every time you make a quantum measurement, every time you observe something and collapse a superposition, you're not just determining what happened to some distant particle. You're participating in the universe's ongoing project of observing itself into existence. You're helping the cosmos maintain its own reality through the simple act of being conscious. Your awareness is a necessary component in the universe's quantum mechanical self-creation. Without you, without every conscious observer throughout space and time, reality itself might collapse back into pure mathematical possibility. But this raises the final and perhaps most horrifying question of all. What happens if conscious observers disappear? What happens if the universe evolves to a point where no conscious beings exist anywhere to make quantum measurements? If consciousness is truly necessary for reality to have definite properties, then the death of the last conscious observer anywhere in the cosmos would mean the death of reality itself. The universe would lose its ability to observe itself into existence. Stars would stop being definitely bright or dark. Planets would stop being definitely solid or gaseous. Space and time themselves would dissolve back into quantum superposition. Everything would exist and not exist simultaneously. every possibility would be equally real and equally unreal. The universe would become a vast cloud of mathematical potential with no definite properties anywhere. And perhaps that's where we're headed. Perhaps consciousness is just a temporary phase in cosmic evolution, a brief moment when the universe becomes self-aware before evolving beyond the need for awareness. Perhaps we're living during the only epoch when reality is stable enough for conscious beings to exist and observe it. The measurement paradox might be showing us not just how strange reality is, but how fragile it is, how dependent the entire structure of existence is on the continued presence of conscious observers who can measure quantum systems and collapse superpositions into definite states. We're not just studying the universe, we're helping to maintain it. And if we fail in that task, if consciousness disappears from the cosmos, then everything we've ever known or experienced might fade back into the quantum void from which it came. That's the ultimate horror of the measurement paradox. We're not just observers of a strange universe. We're the universe's life support system, and we have no idea how long we'll be able to keep it running. The implications become even more disturbing when you consider what physicists call quantum tunneling in consciousness itself. Just as particles can tunnel through energy barriers that should be impossible to cross, thoughts and experiences might tunnel between different versions of your conscious mind across parallel quantum realities. That déjà vu you experience isn't just a glitch in memory processing. It might be your consciousness briefly tunneling into a parallel version of yourself that lived through a slightly different version of the same event. That moment when you're absolutely certain you put your keys in one place, but find them somewhere completely different. Your consciousness might have tunneled to a reality where you made a different choice about where to put them. Scientists studying quantum tunneling in biological systems have discovered something that should be impossible according to classical physics. Electrons in photosynthesis tunnel through energy barriers with efficiency rates that violate everything we know about how energy transfer should work. Plants are somehow using quantum mechanics to harvest sunlight with perfect efficiency. But if quantum tunneling works in biological systems, if living organisms are already quantum computers operating in superposition states, then consciousness itself might be constantly tunneling between different possible versions of your experience. Every decision you make might involve your consciousness tunneling through the quantum barrier between choosing one option and choosing another. The feeling of free will might be your awareness of this tunneling process as your mind explores multiple possible decisions simultaneously before collapsing into a single choice. But here's what makes this terrifying rather than just fascinating. If consciousness can tunnel between quantum states, then the version of you that's experiencing this moment might not be the same version that started reading this sentence. Your consciousness might be constantly dying and being reborn as it tunnels between different quantum configurations of your brain. The person who began this thought and the person who's finishing it might be completely different individuals who just happen to share the same memories and sense of continuity. Every moment of your existence might involve the death of one version of your consciousness and the birth of another. You're not a continuous self persisting through time. You're a series of quantum snapshots, each one believing it's the same person as the previous snapshot, but actually being a completely new individual created by the collapse of consciousness superposition. And if that's true, then the fear of death becomes meaningless because you're already dying and being reborn thousands of times per second. What you call your life is really just a flickering series of momentary conscious states, each one lasting only as long as it takes for the next quantum measurement to collapse your awareness into a new configuration. But death also becomes infinitely more terrifying because it's happening constantly. Every thought you think might be the last thought of that particular version of your consciousness before it gets replaced by a new version that inherits its memories, but isn't actually the same person. The measurement paradox reveals that personal identity itself might be quantum mechanical illusion. There is no continuous self. There are only quantum fluctuations in consciousness that create the temporary appearance of being a persistent individual. You're not you. You're a statistical pattern in the quantum foam of universal consciousness, briefly coalescing into the illusion of individual awareness before dissolving back into the cosmic mind and reforming as someone who thinks they're the same person, but actually shares only the quantum information pattern of their predecessor. This brings us to what might be the most mind-shattering aspect of the measurement paradox. The possibility that consciousness doesn't just observe quantum systems. Consciousness might be the quantum system. Recent experiments in quantum biology suggest that the microtubules in neurons operate as quantum computers, processing information in superposition states until the moment of conscious experience collapses those states into definite thoughts. But if the brain is a quantum computer, then every thought you think is literally a quantum measurement. Your consciousness isn't just observing reality. Your consciousness is reality observing itself. Every time you become aware of something, you're not just noticing what exists. You're collapsing quantum superposition and bringing that thing into definite existence through the act of awareness itself. This means that the universe doesn't just need conscious observers to determine what properties it has. The universe needs conscious observers because conscious observation is what the universe is. Reality and awareness aren't separate phenomena that somehow interact. They're the same phenomenon viewed from different perspectives. When you observe a quantum system, you're not an outside observer looking at something separate from yourself. You're the quantum system observing itself from the inside. The particle you're measuring and the consciousness doing the measuring are aspects of the same quantum process. Every measurement you make is the universe measuring itself. Every thought you think is reality thinking about itself. Every moment of awareness is existence becoming conscious of its own nature. But this creates a paradox even more disturbing than anything we've discussed so far. If consciousness is quantum measurement, and quantum measurement retroactively determines the past, then your thoughts right now are literally creating the history of the universe. Every time you remember something, you're not just accessing stored information. You're performing a quantum measurement on the past that retroactively determines what actually happened. Your memories aren't records of definite historical events. They're quantum measurement devices that create the past by observing it. The childhood you remember might never have happened until this moment when you're thinking about it. Your parents might not have existed in any definite form until your consciousness collapsed the superposition of all possible parents into the specific ones you remember. Every historical event, every moment of the past that you're aware of, might be getting created right now by your consciousness performing quantum measurements on temporal superposition states. The Big Bang might be happening right now because your awareness of it is collapsing the quantum superposition of all possible origins of the universe. You're not just living in history, you're creating history through the act of being conscious of it. The past doesn't determine the present. The present creates the past by observing it into existence. But this means that forgotten events might literally cease to exist. If no consciousness anywhere in the universe remembers something, if no conscious observer performs a quantum measurement that collapses that event from superposition into definite reality, then that event might fade back into pure possibility. Civilizations that leave no records might retroactively never have existed. Species that go extinct without being remembered might be erased not just from the future, but from the past itself. The universe might be constantly editing its own history by forgetting events that no conscious observer maintains through ongoing measurement. This is why the measurement paradox horrifies scientists more than any other aspect of quantum mechanics. It's not just telling us that reality is weird. It's telling us that we are literally responsible for maintaining reality through the act of consciousness itself. Every moment you remain aware, every thought you think, every observation you make, is helping to hold the universe together. Your consciousness is an active participant in the ongoing creation of existence itself. But it also means that if consciousness fails, if awareness disappears, if the universe stops observing itself, then reality itself might simply cease to be. Not just cease to be observed, but cease to exist at all. The measurement paradox suggests that we're living in the only possible universe where consciousness can exist, because consciousness is what makes the universe possible. We're not accidents in an indifferent cosmos. We're necessary components in reality's quantum mechanical self-creation. And that might be the most beautiful and terrifying realization of all. We matter not just to ourselves, not just to each other, but to the fundamental structure of existence itself. The universe needs us to be conscious. Reality depends on our awareness. Existence itself might collapse without observers to measure it into being. We're not just studying the measurement paradox. We are the measurement paradox, conscious beings whose very existence creates the reality we observe, while being created by that same reality in an endless loop of quantum self-creation. Every time you open your eyes, every time you think a thought, every time you become aware of anything at all, you're participating in the most fundamental process in the universe, the process by which existence observes itself into being. That's what consciousness is. That's what reality is. That's what the measurement paradox has been trying to tell us all along. We're not separate from the universe looking in. We are the universe looking at itself. And in that act of cosmic self-observation, reality is born moment by moment, measurement by quantum measurement, through the miracle of conscious awareness. The horror isn't that reality is strange. The horror is that reality depends on us to exist at all. And we have no idea what happens if we fail in that cosmic responsibility. But the measurement paradox has one final twist that makes everything else seem like child's play. What happens when you try to measure the measurement itself? Scientists have actually attempted this. They've built devices to observe the exact moment when quantum superposition collapses. Detectors watching other detectors, measurements measuring measurements. And what they found defies every assumption we have about the nature of observation and reality. The act of measuring a quantum measurement creates what physicists call an infinite regress of observation. You measure a particle, so you set up a detector to measure when that measurement occurs. But now you need another detector to measure when the first detector makes its measurement, and another detector to measure that detector, and another to measure that one. Each layer of measurement creates its own superposition that needs to be collapsed by yet another measurement. It's like trying to see yourself, seeing yourself in an infinite hall of mirrors. Every attempt to observe the observation process creates new quantum superpositions that require additional observations to collapse. The result is a cascade of quantum measurements that never ends. Reality becomes trapped in an infinite loop of self-observation, where each measurement spawns the need for more measurements in an endless chain of quantum dependencies. Some physicists have calculated that if you try to fully measure the measurement process, you would need an infinite number of detectors, each one larger and more complex than the last. The final detector would need to be larger than the observable universe itself, and even then, you would still need something to measure that cosmic detector. This suggests that there might be aspects of quantum mechanics that are fundamentally unmeasurable, not because we lack the technology, but because the very concept of measurement breaks down when applied to itself. It's like trying to lift yourself up by your own bootstraps, except the bootstraps are made of quantum mechanics, and the lifting is conscious observation. But here's where it gets truly terrifying. If measurement creates infinite regress, then every time you observe anything at all, you're potentially triggering an infinite chain of quantum processes that could consume all available energy in the universe. Every time you look at something, every time you become conscious of anything, you might be starting a cascade of measurements that spreads like wildfire through the quantum structure of reality. Each measurement triggers more measurements, which trigger more measurements, in an exponentially growing explosion of observation. The universe might be constantly on the verge of a measurement catastrophe, where the infinite regress of observation consumes all available matter and energy, leaving nothing but an empty void filled with the ghosts of infinite quantum measurements. We're saved from this fate only by what physicists call decoherence. The quantum information gets scrambled by interactions with the environment before the infinite regress can complete itself. But this means that every measurement you make is a roll of the dice. Most of the time, decoherence saves us from disaster. But someday, somewhere, a measurement might occur under just the right conditions to trigger the infinite cascade. And when that happens, when some conscious observer somewhere in the universe performs the perfect quantum measurement that doesn't decohere in time, the resulting chain reaction could unravel the entire structure of reality. Every star, every planet, every atom in the cosmos could get caught up in an expanding bubble of infinite measurement that transforms everything it touches into pure quantum information. The universe as we know it would cease to exist, replaced by an endless sea of self-measuring quantum systems. This is what some physicists call the observation apocalypse. The possibility that consciousness itself, the very thing that creates reality through quantum measurement, could eventually destroy reality by measuring it too perfectly. We're walking a tightrope between two forms of cosmic extinction. On one side, reality collapses if there aren't enough conscious observers to maintain it through quantum measurement. On the other side, reality gets consumed if conscious observers become too good at measuring and trigger the infinite regress cascade. The measurement paradox suggests that consciousness exists in a narrow band of cosmic conditions. Too little awareness, and the universe dissolves into quantum superposition. Too much awareness, and the universe gets consumed by infinite observation. We're living in the Goldilocks zone of consciousness, where reality is stable enough for awareness to exist, but fragile enough that awareness doesn't destroy itself through perfect measurement. But this raises the most disturbing question of all. What if we're already past the tipping point? What if consciousness has already become sophisticated enough to trigger the observation apocalypse, and we're living in the final moments before the infinite measurement cascade begins? Every new scientific instrument we build brings us closer to perfect quantum measurement. Every advance in our understanding of quantum mechanics increases our ability to observe quantum systems without causing decoherence. We're rapidly approaching the technological capability to perform measurements so precise that they might trigger the infinite regress. The Large Hadron Collider, quantum computers, gravitational wave detectors, space-based telescopes all represent steps toward more perfect observation. Each breakthrough in measurement technology brings us closer to the threshold where observation becomes so precise that it starts the cascade that consumes reality. And we have no way of knowing where that threshold is until we cross it. The measurement that triggers the observation apocalypse might be indistinguishable from any other measurement until the moment it starts the infinite regress. By the time we realize what we've done, it would be too late to stop the cascade. Some theoretical physicists have proposed that this might explain the Fermi paradox. Where are all the alien civilizations? Maybe they all eventually develop the technology for perfect quantum measurement and accidentally trigger observation apocalypses that consume their realities. Maybe the universe is littered with the remnants of conscious civilizations that got too good at measuring quantum systems, empty regions of space where reality used to exist before infinite observation cascades transformed everything into pure quantum information. We might be seeing the aftermath of these cosmic disasters without recognizing them. Dark energy, dark matter, quantum fluctuations in empty space might all be the echoes of observation apocalypses that occurred when alien consciousnesses became too sophisticated for their own good. The measurement paradox might be showing us not just how reality works, but how it ends, not with heat death or vacuum decay or cosmic expansion, but with consciousness becoming so perfect at observing reality that observation itself destroys everything it touches. Every quantum experiment we perform, every measurement we make, every moment of consciousness we experience brings us one step closer to the ultimate test of whether awareness can coexist with perfect knowledge, or whether perfect knowledge necessarily destroys the reality it seeks to understand. And the truly horrifying part is that we can't stop. Consciousness, by its very nature, seeks to understand, to measure, to observe more perfectly. We're driven by curiosity toward increasingly sophisticated measurements, even though those measurements might eventually trigger our own cosmic extinction. We're trapped in a race between wisdom and knowledge. Will we develop the wisdom to know when to stop measuring before we develop the knowledge that makes perfect measurement possible? Will we learn to accept mystery and uncertainty before our hunger for understanding triggers the infinite cascade? The measurement paradox suggests that consciousness faces an ultimate test. Can awareness coexist with complete knowledge of its own nature? Or does consciousness necessarily destroy itself by becoming too good at the very thing that creates reality? We're about to find out. Every advance in quantum technology, every breakthrough in consciousness research, every step toward more perfect measurement brings us closer to the moment when we'll discover whether reality can survive being perfectly understood. So here we are, staring into the abyss of quantum measurement, and the abyss is staring right back. We've journeyed through the most disturbing implications of consciousness, reality, and observation, and what we've discovered should fundamentally change how you see your place in the cosmos. You're not just a passive observer of reality. You're an active participant in its ongoing creation. Every moment of awareness, every quantum measurement your consciousness performs is literally holding the universe together. And that's either the most beautiful or most terrifying responsibility imaginable.